Okay, here's a good example of a limit where L'Hopital's rule is going to make it easier, right? So if I put 0 in here, we find out that the tangent at 0, which is sine over cosine, which is 0, and the log of 0 doesn't matter because we already know 0 times anything is 0, but the log as x approaches 0 actually goes off to positive infinity. Um, so we need to find another way. So we're going to take the derivative of a rational function. So first we need to create a rational function, and I'm going to do that by thinking about tangent as its reciprocal 1 over cotangent. So I can think of this as the log of x over cotangent of x. Now applying L'Hopital's rule, that means I take the derivative of the numerator and derivative of the denominator. And when I do that, the derivative of the log of x is 1 over x, and the derivative of cotangent x is negative cosecant squared x. And if I rethink this so that I don't have it as a complex compound rational function, what I can do is we know that 1 over x means I can put the x in the denominator, and the reciprocal of cosecant is sine, so I'm going to think of this as negative sine squared x. And now you can really see L'Hopital's rule and why I would use it here, because if I put 0 in, I get 0 over 0, which means I still don't know my answer, so I'm going to apply L'Hopital's rule again. So when I do that, I'm going to take the derivative of the numerator separate from the derivative of the denominator. Derivative of the numerator, remember the derivative of sine is cosine, but I have to apply the chain rule. So I get negative 2 sine x times the derivative of sine x, which is cosine x. Derivative of x is 1. So now I no longer have a case where the denominator to be 0. And now when I put 0 in here, the sine of 0 is 0. So I get negative 2 times the sine of 0, which is 0, times the cosine of 0, which is 1, which means that the whole thing equals 0. So the things to keep in mind is I'm taking the derivative of the numerator and the denominator separately. If I still have an indeterminate limit, I'm going to apply L'Hopital's rule again and take the derivative of the numerator and the derivative of the denominator separately. I hope this helps. This is number 24 from your textbook.